Hey, welcome to Dev Better, the show where we talk about organizational and software engineering challenges that we have encountered as a software engineering consulting firm. Today, we're going to talk about so you want to be an engineer. What are some things that you should learn or perhaps think about in order to break into the field of software engineering? Software engineering has long been perceived as a field that is gatekept by strict requirements, such as possessing a college degree or working for big tech companies. This perception has created barriers for individuals without formal education or access to opportunities in larger organizations. Unfortunately, this gatekeeping mentality has contributed to a lack of diversity in the industry, particularly with regard to women representation, but also people of color and other members of minority groups. To address this issue, my company, 7Factor, has recognized the need to invest in STEM education and create opportunities for underrepresented communities. Our apprenticeship program provides individuals with the necessary resources, support, and role models to develop their skills in a focused and encouraging environment. By offering an alternative path to gaining experience and knowledge, our programs and ones of similar nature aim to bridge the gap and increase diversity within the industry. One example is Katie, who participated in 7Factor's flagship apprenticeship program. Through a rigorous vetting process and hands-on experience, she gained valuable insights and skills. Katie's success story serves as an inspiration for others who aspire to break into software engineering. It highlights the importance of seeking out alternative learning opportunities and being resilient in pursuing a career in technology, even without a traditional educational background. It also underscores the significance of companies investing in programs that provide access and support to individuals from diverse backgrounds. The industry is highly competitive and increasingly daunting. It can be hard to know where to start, where to go to college, or whether you should even go to college in the first place. These are questions that Katie and I will help you answer. By giving our experience, sharing her story, we hope to give some perspective and a better understanding of the battlefield ahead for future software engineers. Hi, Katie. How are you?
Hi, I'm doing great. How are you?
I'm doing great. I'm so happy to have you on. So the first question I want to talk about is, what made you decide that going into software engineering was a thing you wanted to do?
Oh boy. I was feeling pretty stuck in the retail industry where I was before, and not really having much room to grow, and I wasn't being challenged. And I've always had a passion for technology, software, video games, I mean, literally everything. And I just started playing around with some courses online and discovered that I have a huge passion for technology. And I just wanted to try something new, try something that was going to challenge me, and it's only gotten more fun ever since I started picking it up. So,
Yeah. So why do you think it's so hard to get started in a career in software engineering or technology really in general?
absolutely. I think it's so I don't think for a while I really knew what software engineers do. It's very abstract from an outsider's perspective, and I think that makes it quite intimidating. Also, coming from non-traditional backgrounds, like not pursuing a bachelor's degree or going to a formal college, I think it seems like something that is completely unattainable. And that's something that I had to research a lot about, and that's why I'm grateful that there are programs like I went to, like boot camps,
Hmm.
apprenticeship programs, thanks to 7Factor, things that I can do that will help me get into that industry without having to necessarily pursue a computer science degree.
Yeah, and I think a lot of folks come from boot camps. I used to teach at a boot camp here in Atlanta for a brief period of time, and the curriculum there is designed very well for folks that are coming out of non-technical positions that want to start learning about coding and how to become a software engineer. So, talk to me about some things that you learned in boot camp that set you up for success, and maybe also discuss a few things that sort of came out of nowhere that you weren't expecting.
Yeah. The boot camp was great. My boot camp that I attended, we learned three full stacks. So we had a Python stack, a Java stack, and a Mern stack. And I think it gave me a very good understanding of how programming works, how things are read by computers. I don't think without that boot camp, I would have had an understanding of how programs run
Hmm.
essentially. um, I think they did a lot of really great job, teaching us uh, things like algorithms, for loops, while loops. Learning things like that was great, and I'm going to use that everywhere. On the flip side, some things that I wasn't really prepared for was any type of software architecture. I think we had a lot of kind of boilerplate assignments that you would set them up all the same way,
Hmm.
and coming into a real world, it's not usually that simple at all. In addition to writing tests, that's a huge thing. I think I was really glad I got exposed to at Seven Factor. I had never written a test in my boot camp whatsoever, and it's a short amount of time. They pack a lot of stuff into there, so I can understand. But I do think learning how to test, especially as a junior programmer, it's so important to know what you're doing is working, why it's working, and be able to test everything and not mess things up along the way, and just get completely lost. So
If I can inject my opinion here to any boot camp curriculum designers who are listening, one of the biggest issues I have with most boot camps, and again, they're fantastic for what you get, is that there is never a conversation around testing. We try to use test driven development at Seven Factor where we can. So certain clients don't necessarily think that it is a good practice, and that's okay with us. If left to our own devices and you put us all in a room and say, all right, do what you want, we're going to be doing things like mob programming, pair programming, test driven development. We're going to focus on implementing the right size solution for a target problem, which is a good thing to learn, uh, in my opinion, at that boot camp level. So when I taught at boot camp, I had sort of the same experience as Katie did, where the curriculum that I was teaching had no room for testing, but I made room anyway. Because I think that as a junior programmer, learning how to test is one of the most important things you can do because it sets you up for success in the future. And you mentioned architecture. That just comes with experience, right? The more time you spend working in the field, the more exposure you get to platforms and to things like load balancers and subnets and VPCs and VPNs and S3 buckets and all of those things. That's terminology that you can sort of pick up. And that's my next question. So what surprised you with how quickly you were able to learn? Was it cloud? Was it testing? Was it just general software patterns? Talk to me about something that it just clicked with you, and you're like, this makes sense.
I'd say testing really clicked with me. It was almost funny that I hadn't really heard a whole lot about test driven development prior to coming into the apprenticeship, but it made perfect sense as soon as we started writing them, before implementing things. When you have all these moving parts, knowing that one change you make isn't going to mess up a bunch of other things that are happening in your code, it's a great feeling, and it really helped me understand. I really liked how we wrote things in very readable language. We could look at our code base, and we don't just have these like obscure named functions. It's very clear what everything is doing. It took a long time to get that way, absolutely, but it made writing tests easier. Everything about that really clicked. I'd say the cloud stuff was pretty. I was pretty lost, in like first exposure to the cloud, like AWS. I had deployed some personal projects prior, but I really didn't have an understanding of any cloud concepts. That took a little while, but eventually really started to click. I saw why we did things the way we did, and that was wonderful. That's something I probably became most passionate about.
Yeah, I think that's for us part of the sizzle is when we work with clients and we bring apprentices in is we focus on teaching them the entire life cycle of a deployed application, right? And some companies have their own DevOps organizations, and that's completely cool. But we teach our apprentices how to architect in the cloud, which is a thing that most people is like a title. You know, they live in the ivory tower and they decree from upon high how thou shalt and shalt not deploy thy software into my golden environment. Cloud has changed the game there, where a novice can boot up an Amazon account, right click on a few things, and click a few buttons, and they have a running environment that you're paying real money for, but you can build real applications in no time. And again, there's only, I think, 970 services, Katie. Like, good Lord, why couldn't you learn all of those? There's so many things in Amazon, and it's such a broad, and it's an amazing platform, and Azure as well. Both are really good platforms. GCP is kind of one we don't see very much because we're not deep into retail, but it's also got its strengths. Each of these platforms have changed the game with respect to how one actuates the apparatus that is deploying my applications into these target platforms. So it's not uncommon for a novice developer to walk into a cloud situation and say, "Holy cow! What's an S3? What's an EFS? What's a VPC? What's a subnet?" And I think the power of our apprenticeship program is that we give folks that the access to those things almost immediately, and we immerse you in what it means to deploy and develop applications in the cloud, and that helps accelerate your learning. So, talk to me about your work ethic. How much time did you put into this? I don't want to. I don't want to. I don't want to sugarcoat the fact that going from 0 to level 1 is very, very hard, and you've done a phenomenal job of that. So, talk to us a little bit about how much work you put into this.
Yeah, like I said in the beginning, I was really just starting off learning the basics, just kind of doing some algorithms online, taking some really basic courses, and then in the boot camp, it was definitely a grind. I wanted to do every single assignment given, whether optional or not optional, and I wanted to do it the best way possible. And that would honestly maybe take me a couple more hours to complete an assignment versus some of my fellow bootcamp grads. And then coming into the apprenticeship, I knew it was going to be tough. I knew I was going to get exposed to a whole lot of things that I had never ever seen. When I was first accepted, they let me know that I'd be working in C#.net. So first things first, I wanted to learn some syntax about C#.net, kind of the similarities and differences to Java, something I had a little bit more practice with. But then once getting into getting into the apprenticeship, I it totally took off on a whole other level. I don't think there's anything I could have studied that would have given me even close to as much knowledge as I gained working on real world applications. I really actually didn't have to pay attention to things like syntax nearly
Right.
as much because our IDEs handle that for us so well. But really learning these problems and working with people who say, okay, this is what I want, and then translating that into technical terms versus coming from like the boot camp. Everything is kind of technical. They're like, write a program that does this, and they kind of explain exactly what they need you to do. When you're working with a client with real world issues, it's not going to be like that. But I put a lot of time in during the apprenticeship, learning about the cloud things. While we're in our meetings, I would be writing down terms that I had never heard of before on a sticky note, and like, okay, when I'm done here and I have a break, or when I'm done for the day, I'm going to look up these terms and figure out what they mean so I can be part of the conversation next time they talk about these things. So that definitely took a lot of time, a lot of terminology. There's a lot of jargon, as some say, in the technology world, which I think is part of what makes it so intimidating. But that was a lot of effort, definitely from my end, and then coming out of it, I've spent a lot of time studying to get my AWS certs, trying to work on personal projects, and just getting a little bit deeper into C#.net, as well as software architecture. So
Yeah, I want to say that louder, that experience trumps academic knowledge in this field. And it's completely true because I came through, what you would call a traditional computer science degree, right? I have a master's in computer science from Georgia Tech and a bachelor's and all this. And I loved my time there and I learned so many things. But when I walked in day one at Danger, everything that I knew was pretty much torn to shreds with respect to my expectations of working that job. The problem solving ideas that I learned and all of the difficult classes that I took that taught me work ethic, those things still stayed true. Just like boot camps are going to teach you the basics of how to walk in, understand some technology, how to actuate your machine, how to search for something, how to spend time learning. Like those are the really good things you should focus on in a boot camp or in a traditional CS degree. But when it comes to learning on the job, that is what we do, right? The definition of a software engineer in my mind is someone who can walk into any situation full of ambiguity, make sense of the ambiguity, and sort out the right path towards getting some operating code that's hopefully tested that will produce some output for a client, for a business stakeholder. And I think you learn that walking into your client, and the client we put you on specifically for this reason was very ambiguous, and there were lots of question marks, and really it was kind of an open forum for you to walk in and just mob with the team and pair program with the team and execute. What were some of the processes, speaking of mobbing and pairing? Talk to me a little bit about how those helped accelerate your learning.
Yeah, absolutely. Mob programming became my favorite thing during the apprenticeship, and I'd love to be able to continue that wherever I go. I absorb so much information mob programming because we have a group of developers of all different experience levels, but besides that, they also explain things differently. They have different voices, and hearing a bunch of different people come together and try to explain a concept to somebody else, whether that's me or somebody else on the team, really made a huge difference instead of just hearing it necessarily from one person. Also, in mob programming, you're always in the loop, but it's not quite as intimidating as maybe being assigned to something completely by yourself. Because if you're going about something and that maybe I think this is the best way to go about this, but I have somebody watching with me and say, oh no, actually I would try going about it this way, and then there's other people to back them or back my opinion, and you get really weighing the pros and cons of doing things, and you get fresh ideas that maybe you would have never thought of. I think we all can learn from mob programming, whether you're an entry level developer or senior distinguished engineer. You'll be able to learn from each other, just taking different approaches to things and constantly being involved in actually writing code, helping somebody else write their code, observing. I mean, I don't think I could have asked for a better learning experience than mob programming.
So refactoring, it's a thing that is never taught. I was not taught refactoring in my CS degree at Georgia Tech. I didn't know what it was until I read some material from Kent Beck and I started learning what test-driven development actually was. Describe to me how refactoring changed how you think about writing production code.
Oh my gosh. First and foremost, I think it helps me break down the problem into smaller parts. And starting with, okay, let's just get this to work. Let's just get it to do the minimum amount of work we need to get a test to pass. And then going back and making it better, because you may need to use that logic elsewhere, or it's completely unreadable because there's so many things going on in one function. Anybody else who steps into it won't have any idea what's going on. I never really looked back at my code prior to learning about refactoring. It was like, okay, it works. I'm just gonna leave that. And
Right.
oh man, refactoring, splitting things up and really making things as optimal as possible made a huge difference.
Did it add any additional time to your work cycle? Because this is a common argument I get, and you know what I think, but I would like to hear from you. Be honest. Did it really add any time to your work cycle?
I would actually say it didn't take more time. And the reason I'd say this is really like one of my first tickets that I worked on during the apprenticeship. I just went ahead and I was like, I'm just going to get this all to work and I'm just going to accomplish it. And backtracking and having to undo the things I did because I didn't do them the simplest way possible, or I wasn't writing these really basic tests to get everything to pass. I probably doubled my time and ended up kind of doing the refactoring afterwards, after I'd gotten some help from my mentor, and he said, try approaching it this way. I think if I'd approached it that way from the beginning, although it seems like in my head that it might take longer, it usually ends up being faster because you don't have to backtrack. It seems like everything is moving forward, and you're not having to undo a bunch of mistakes that you made before, which of course can add a lot of time and also become very confusing.
Right. And I think so. We like to follow Occam's razor here, right? Which is the simplest answer is probably the correct answer. Refactoring facilitates that in your code. It's a reason why we like it a lot. I've fought some battles on the client level before about folks having the perception that refactoring is a waste of time and that it doesn't get production code out. And that's true. It doesn't. But it doesn't provide much of a block in your capabilities of getting good software out into production, even when you're trying to move quickly. So I think that's a thing I love to hear you say, and I would like to see more of that taught across boot camps and in company apprenticeship programs. Is that refactoring really is a linchpin to building good software, and you need to go back and reread what you did. You don't want to get caught in the trap of sort of cyclically rewriting and rewriting and rewriting. That's a different problem altogether. But to come in and see small functions that sort of compose and read like a book, right, from top to bottom, left to right. If I can read a function like a book and understand exactly what it's doing, and then turn around and look at the test and understand what the test cases are doing, and those two things in tandem, give me a simple understanding of what that system is supposed to do, then you've pretty much arrived, right? And you can pause your refactoring
Right.
for a moment until you add an additional feature to it.
When it's your own code, you don't think about how anybody else would come into this and try to understand it. When you're working on a big project with other developers and you know it's like this code you write, it could potentially be there for decades. You want all the people coming in after you to know exactly how that works so they don't spend time trying. And that's why I think refactoring does save time. Maybe
Mm-hmm.
not initially, but when I come back and I want to add some logic or change something that I had working before, looking at a 50 line function is going to be terrible for me. I'm going to have a horrible time trying to figure out exactly what I need to do. Having these smaller functions with descriptive names and everything really optimal is so nice for somebody coming in into a code base that they didn't touch before. Otherwise, you'd be completely lost.
Yeah, and we tend to not think about the cognitive load of reading code, which is a thing I'd love to see some additional research done at a broader level at a Google or a Microsoft if you're listening or watching this, having an understanding of what it means to walk into a giant code base and seeing how quickly you can ramp into that versus if you had a smaller, tighter, more easily understandable implementation, how quickly can you add features to that? I would love to see some more information and perhaps some studies done on that. So cool. What now that you've been through the apprenticeship program, what are some things that you would say people who are just starting out need to focus on?
I think people need to. I think having a broad understanding of multiple languages can be really helpful because
Mm-hmm.
like in at the apprenticeship, you don't know what language, what frameworks you're going to be working on, especially in consulting, because it kind of depends on the client sometimes. Um, but I think really diving deep into like one like object oriented programming language like C sharp or Java and really getting a deeper understanding is going to take you a lot further because you can actually transfer those skills into other frameworks. A lot of the logic is very same in different languages. So I think really focusing on that. I also think being curious is I think what's taken me so far. You look at a code base and or you find a solution
Mm-hmm.
to something you're working on and you don't understand why it works, but it works. Figure out why, and you will have a much easier time implementing similar things in the future. I know there's some things that, depending on like a project you're on, sometimes you just gotta not look at something. I know we say black box, but as a junior, I think understanding some concepts a little bit deeper is a really, really, really great idea. You know, depending on what you want to do. I spent a lot of time on HTML and CSS with absolutely no desire to be a front end engineer or designer of any sorts. I think if I had used that time to dive deeper into the back end technologies I've been working on with now, or into cloud technologies, that would have been a better use of my time.
Yeah.
But of course, I think it takes some people some time to figure out what direction they want to go in. I wasn't really sure if I liked front end or back end until after the boot camp. But at the end of the day, I don't really spend time working on CSS now because I don't want to be doing that. I want to be spending time, working with databases, and that's what I'm going to practice doing then as well.
Yeah, people make fun of me in the company still that I can't center a div. In CS, which the silly thing is there's like 900 ways to center it. Maybe Flexbox fixed all that. I don't even know. But of the apprentices we had, 2 of you were back end and 1 of you was more front end oriented. And I remember having our final chat with each of you and driving that point home that full stack is a thing and it's important. And you do need to understand how front end technologies operate. And you need to be able to work in front end technologies in order to efficiently create contracts from a back-end perspective that they can use. Well, with GraphQL these days, you just slap that in front of it and you're good. But there's a lot of concepts that you can learn from a functional programming perspective on the front end, and there's a lot of concepts in the back end. But I agree and would like to encourage anyone watching this, if you're coming from a boot camp, they're going to sell you the full stack thing, which is fine. But you really need to focus on one specific area and get really good at it before you branch off, right? There's this concept of Kent Beck calls it paint drips, right? Where you kind of draw a line and there's various little drips that come down from that line. And you're going to go deep in certain technologies, like maybe as a back-end engineer, you're super deep in SQL, you're kind of deep in Java, you're kind of deep in C#, which those two are OOP, so they're kind of similar. They're just different frameworks and different syntax sugar around how you operate those 2 languages. And then as you continue to move through your career, these drips are just going to get deeper and deeper and deeper. And then you're going to notice patterns across those drips, right? Especially if you sit on the back end. If you sit on the front end, maybe you're more interested in user experience, UX, design, animation, CSS, things like that. I mean, you can be a very technical software engineer and build code in React using good OOP patterns, which I don't think they actually recommend anymore. That shows my knowledge in React these days. But you still need to focus and specialize in one of those 2 areas, because what that's going to do is it's going to give you the ability to jump across these different pieces and to become more valuable to your employer. And I like what you said, that maybe if you had spent more time working in cloud or something of that nature, it would make you a little bit more marketable and perhaps even more desirable as a candidate. And I would agree with you. As someone who hires engineers all the time, I don't look for full stack on their resume. I know, again, a lot of people do, but I look for folks that have a demonstrated track record of success in a specific set of problems before I will bring them into the next round of the interview, because what that does is it proves to me that you can hold attention and you can sit there and you can work and work and work on getting really good at something before you cross off into these other specializations and maybe you jump over here and do some front-end stuff. But that's a really good point. And yeah, so thanks, Katie. That's really all the questions we have. I'm very appreciative of you. Thank you for going through our apprenticeship program. I really hope that you got a lot out of it. You guys should check her out. We'll put her LinkedIn in the description below. I believe you're still open for work. She's a fantastic human being, super smart, did a lot of really great work for our clients. So check her out. And thanks a lot, Katie. We'll see you next time.